James is working in the automation team, and he describes his own job as, I quote, improving interoperability through testing. So James has worked for Opera. He is a British citizen, but he also has a Swedish card. And I've been told that he was especially fond of hamburgers, but the very good one. So please welcome James.
Okay, we're just having some minor technical problems getting the slides working, but I'm here to talk to you today about testing for the web. So the web, I hope everybody in this room can agree, is pretty great. It's got a lot of things going for it. It's vendor neutral. You can implement it on any device. You don't have to go out to someone and get permission to distribute your content on the web. But it also has a number of problems. So one of the problems that I think we've really seen recently with the rise of mobile operating systems is that the web doesn't necessarily have all the features that other platforms have. So performance, or it might not have access to hardware. And there's a pretty simple solution to that. Which is that you go, okay, we need this extra feature. Let's go and convince some browser vendors to implement it. Let's get together and write a spec, and let's do it. So we know how to do that. But there's another problem with the web, which seems to sort of be fundamental to the whole model. That well, if you've ever developed a website, you've probably found that you developed it in one browser, and then you tried it in some other browser, and it didn't quite work. And that's a bit more of a problem. And this is really something that's been going on for a long time. 10 years ago or more, we were getting best displayed in Netscape 4 or whatever, and then we got best displayed in Internet Explorer, and then best displayed in WebKit, and Internet Explorer isn't going to work at all. So this is something we'd really like to fix. So what's the process for doing this? Well, typically, if we have bugs and we want to fix them, then the first step is to write a test. So maybe the right solution to improving the web here is to write some tests that we can use to say, well, there's a bug, we need to fix it, and we can all see what it is. Okay, and people have written tests before. You might recognize these. These are two of the acid tests, and they were written mainly by Ian Hickson, who now edits the HTML spec. And the idea was that they would test a whole bunch of things together so that when you implemented a whole load of different features and fixed maybe some bugs that you had, then you would render the acid test the way that it was intended. So the top one is acid 2, and if you got that right, you would get the smiley face, and the bottom one is acid 3, and you would get this 100 out of 100. If you did it right. And they were great. They really encouraged people to think about web standards and compete on implementing features at a time when that wasn't really maybe as much of a priority as it is today. But they also had a few problems. So one of the problems is that an acid test is a very sort of self-contained thing. Like once it's finished, it's done, and you can't like go, oh well, I found this other bug. I want to add it to the test and make browsers all fail again, because they'd be pretty annoyed at you if you did that. And so it wasn't really possible for people to contribute to them. And also they kind of set some weird incentives because people wanted to do well for them for marketing. They would often make quite shallow implementations of the features and just do enough to pass the test. And this was a particular problem with ACID 3 actually, because there were a couple of browser vendors really competing to see who could be the first to release a build that got 100 out of 100. And so there were stories of people literally just putting in stub methods that sort of did, return true for this, but don't actually implement the feature at all. So in that sense, we'd like to do a bit better. So The question is, what do we really mean by better? So what would be an ideal test suite for the web? Well, it should certainly be automated or automatable. And what I mean by this is that it should be possible to either from within the browser or by scripting the browser from the outside, work out what the result of the test was without actually having a human involved. And so I'm in the tools and automation team, so I kind of have a vested interest in this. But the way that I like to explain it is that if we have an automated test, we can run it 100 times a day, easily. We can put it on our continuous integration hardware and run it 100 times a day. If we have a manual test that requires somebody to sit down and actually do it, we can probably run it once every 100 days, because we just can't afford to employ all the people to run these tests. And it sounds pretty obvious, but actually this is something we've got wrong in the past. So for example, CSS 2.1 spec had a big test suite, hundreds of manual tests, impossible to run. It took one person 2 full days to run it. So the result is that nobody does. It should be vendor neutral. So it should be possible to write a test in this and see if it passes in Gecko and Blink and WebKit and IE and Servo in the future and whatever other engines you care about. And again, it kind of sounds obvious. You know, the web is supposed to be a sort of vendor-neutral platform, but actually at the moment, every browser vendor has their own test suites, and they're completely separate, and they typically depend on proprietary features. So for example, Blink and WebKit have a type of test called a fast layout test, which actually dumps internal data structures and then compares it to the expected internal data structures. And because they're different to the internal data structures of Gecko, we can't use those tests. And there's similar tests that we have that they can't use. It should be possible to run in continuous integration. So this sort of follows on from the point about automation, it being automated. And more than it should be possible to run in continuous integration, it should actually be run in continuous integration. We should do everything we can from the start to make sure that this is something that browser vendors will put on their test systems and run hundreds of times a day. So we need to make sure that it's got a completely replicatable environment so that when you write a test, it's exactly the same as when the browser vendor runs it, so they actually see the fail that they expected. And it also means that we have to have a certain quality standard. We have to have tests that always produce the same results, so that we're not continually having to work out, well, did it just fail because the test was a bit dodgy? And the last point is anybody can contribute. And this is kind of the central point of my talk, that actually it's not just people that work at browser vendors that might want to contribute to this, or people who work on browsers in their spare time, although those are also great people to contribute. But if you develop a website, you might be the best person to contribute a test for something, because it's quite likely that you will come across a bug at some point, and you will see a rendering difference between two browsers, and then you might be the person in the world who has found this bug. And so it would be great if you could also be the person that causes it to be fixed, so that nobody else ever has to find it again. So it sounds like what I'm describing is basically an open source project for tests, and so that's what we've created. So in this case, we is basically the W3C, who are sort of coordinating the effort in the sense that they're providing some infrastructure for it, and they own this brand, Test the Web Forward. You might have heard of Test the Web Forward before. It's historically been used to describe a series of events that were originally run by Adobe, where people would turn up and they would learn how to write a test for the web platform, and then they would contribute their test. So previously Test the Web Forward was these events. Now it's actually the sort of brand name for the whole project. And obviously it has a website, testthewebforward.org. And so if you literally listen to nothing else I say for the rest of the talk, but you remember testthewebforward.org, then that's really all you need to know, because everything else I'm going to say is covered on that site in much more detail. Okay, so it's an open source project. We're running it like a typical open source project. We have a GitHub page. It's a bit hard to read on the screen, but there's a repository in the W3C organization called Web Platform Tests, where we have all the tests for almost everything. There's only two sort of parts of the web platform, really, where we're not collecting the tests in this repository. One of them is JavaScript itself, because it's run at ECMA and it has its own test suite already. We haven't taken JavaScript tests. And the second one is CSS. And the reason for this is basically historical legacy. There's a separate repository for CSS tests, and that's because they took testing seriously earlier than quite a lot of other kind of W3C working group type people. And so they have their own infrastructure which their tests depend on, but nobody else's use. And so we're working on migrating the CSS stuff over to this web platform test repository, but we're not quite there yet. And as is typical for GitHub, we just use the normal GitHub workflow. If you want to contribute a test, or if you want to fix a test or something, you just create a pull request, and then it will get code reviewed, and when it's all right, then we'll integrate it into the repository. Okay, so that's enough kind of background. Let's actually get on and write a test. So, as I've said, it's documented on testthewebforward.org. Testthewebforward.org is another GitHub repository. You can contribute documentation fixes. That's a very useful contribution if that's what you're into. But to write a test, we need an example of something that's broken, really, because if you're a web developer, this is the most likely kind of scenario that you're going to be in. So the example I have here is with an API called FileReader. And if you haven't used FileReader, don't worry about the details of it. You just need to know that it has this method called abort on it. Basically, a FileReader is something you can use to access the contents of, say, a file that's been picked through input type equals file. And in our example, what we see is that we create a file reader, and then immediately we call this abort method. And in Firefox and in Blink-based browsers, two different things happen. So Firefox here will throw an error, whereas Blink-based browsers will just continue without throwing an error. And so obviously these behaviors can't both be right. So what are you going to do? Well, you might then think, okay, so which is the right behavior? So you put FileReader spec into your favorite search engine, and you probably come back with something like this. And it's quite hard to read on here, but this is a W3C specification for the file API. But there is a trap. Typically, the search results that end up at the top of Google, certainly, are for what the W3C calls TR versions of documents. And these are always out of date. It really helps if you just think that TR stands for totally wrong. So whenever you see a TR document, you should look for the bit that says latest editor's draft, and you should click on that instead, because that's the only way to be sure that you're reading the right version of the spec. So just to emphasize it. Okay, this is a little hard to read. Okay, so then we find the right version of the spec, and we find the bit about the abort method, and it says, when the abort method is called, the user agent must run the steps below. If ready state equals empty, or if ready state equals done, set result to null and terminate this overall set of steps without doing anything else. Well, okay, ready state, it turns out here, if we follow the link that's in the spec, is actually set to empty when the file reader is first created, and we haven't done anything that will change ready state yet, so it's empty here, and this first step applies. And then it says, so set result to null and terminate this overall set of steps. Okay, so that tells us that, well, it doesn't tell us that we have to throw an error, so clearly what Firefox is doing here is wrong, and what the other browsers are doing is right. So now we're going to turn our sort of miniature example into a proper test case that's ready for submission. So this is our example from before, just put into a document. And the first thing we need is a little bit of boilerplate. So we have this script, testharness.js, which provides the sort of testing framework. It's quite specific to this test suite. It's not something that people have really used in other JavaScript frameworks, and that's basically because it's designed with testing browsers in mind. So that's why we haven't reused whichever other JavaScript library you've previously heard of. And we also have this file called testharnessreport.js, and that's basically to help browser vendors integrate this in their continuous integration system. So that file is for them to do whatever they like with in order to report the results back. And then we have a little bit more. We have this div id equals log, and that's just somewhere to dump human readable output so that you can tell whether the test passed or failed. Okay, and then one more thing that a test needs is a title. In this case, we're only going to have one test on the page, so we can just add a title element, and that will provide the test title. Okay, and then the last step, or almost the last step, is to turn the code into an actual test. It turns out testharness.js provides this function test, which itself takes a function, and if the function that you call it with runs without throwing any errors, then the test passes, and if it throws an error, then the test fails. So in this case, that turns out to be exactly what we want. So we can literally just strip out all the try-catch stuff, and we immediately have our test. And the reason for having this thing where we pass in a function is that it allows us to isolate different tests on the page from each other, so that we can have multiple tests on the page and they won't interfere too much. So that's a valid test. We could submit that at this point, but we can do a little bit better, and we can see a few more features. So if we look back at the spec, it said, if ready state equals empty, set result to null. So it turns out, if we read about what result is here, result is an attribute of this file read object. So if implementation is really compliant with the spec, then at the end of this process, we should have result equals null. So we can add a test in for that. So testharness.js, it provides a lot of assert functions of the type that you might be used to if you've used a lot of other kind of XUnit type testing frameworks. In this case, we just want assert equals, and we just assert that reader.result is null. So that's pretty straightforward. If it's not null, then this will actually throw an assertion error and the test will fail. Of course, we have more than just assert equals. In fact, one of the design goals has been to have quite a rich range of assertion APIs, so that instead of everybody having to reinvent their own way of testing things, we can just use pre-written functions. So for example, if the write behavior here had been to throw, then there would be assert throws already provided for you, and you would just pass that a function that you would expect to throw, and you could tell it, I expect this function to throw this kind of error, and it would do all those checks for you. You wouldn't have to write any try-catch blocks or anything. And similarly, there's things like assert regexp equals, assert array equals, and so on, for more complicated kinds of checks. So that's great. We've actually there, in just a few minutes, gone from having a difference between browsers to having a test. We need to run the test, and you might think, well, this is a bit problematic. If I want to run it on my system, I've got these paths to /resources, which doesn't really exist on my computer, maybe. So how am I going to check it? Well, as I said before, one of the big goals that we had was to make the test system very self-contained. So we actually distribute in the repository a web server and a WebSocket server that are specially designed for writing test cases, and there's a setup script so that when you run it, you get them launched in the right configuration. So if you go to the repository and read the README file, then basically all you have to do is you have to set up your exec hosts to have the right domain names on your local system, and then everything will work just like it would on a browser vendor's system. So there's no like fiddling with Apache or mod PHP or any of this stuff that's a complete pain. And then we can actually run our test. And I don't really believe in demos because they always go wrong. So here's one I made earlier. This is it in Chrome where it passes. And this is it in Firefox where it fails. And before you run out and file a bug, there is already a bug filed. And it, in fact, already has a patch in it. So hopefully, in the near future, I'm going to need to find a new example to use in this kind of talk, because this one will be fixed. OK, so now that we've got a test, and we've checked that it works, we can submit our test. At that point, somebody, for example, me or one of the other people that works on this, will do code review of the test, and eventually it will get integrated into the repository. OK, so my example test there was a JavaScript test, which is the best type to write whenever you can, but sometimes you can't, and you need to test something that depends on layout. And when you want to do that, the test type we have is called a ref test. What you do here is you make two different pages that when the test passes should render the same, and when the test fails should render differently. So typically what you might do is, say you have a test involving Flexbox, you would make one page use Flexbox and say render a green square, and one page use just normal positioning and render the same green square. And then obviously when Flexbox is broken, you won't get a green square, you'll get something else. So that's how we automate tests that can't be simply automated through JavaScript but depend on layout. And when we can't do that either, we finally resort to manual tests. But this is really a last resort. And in the future, we're hoping to replace all the manual tests with, or as many manual tests as possible, with WebDriver tests. So if you have experience working with WebDriver, sort of Selenium, then we have a job for you, converting tests. OK, so that's what you can do for vendors. But what about vendors? Are they holding up their side of the bargain? Are they actually running these tests yet? The news is good, although we're not all the way there yet. So at Mozilla, we now have these tests. We have some of the tests running on production, and we have the full test suite now running on our staging servers, so as of last week. And on Linux, we're getting like 4 or 5 tests that are unexpectedly erroring on each run. On other platforms, there's more, so there's more work still to do. But certainly in the near future, we're going to be running all these tests, and we have scripts so that we can update it almost as soon as new tests are accepted. I've also seen work in WebKit and heard about work in Blink to get this running. So it definitely looks like, at least for the open source browser vendors that I know about, sort of within the first half of this year, everybody should be running this complete test suite on their sort of continuous integration setup. Obviously, knowing what, say, Microsoft are doing is a bit harder. OK, so the last point I have is that if you're here, you're a great person to write a test. And you should really want to write tests for this test suite. If you're a web developer, then writing tests is a way to ensure that the web sucks less in the future. It's a way to ensure that the bug that you found today isn't still a bug 6 browser versions later. And that's doubly true if you're writing some sort of JavaScript framework. In my ideal world, if you were writing a JavaScript framework, you would have a policy that every time you had to hack around 2 different browsers having different behaviors, you would write a test. We would provide you with a link that told you what the behavior of that test was in the latest version of each browser. And then as soon as it passed in all the browsers that you supported, you could remove your hack, and you could be completely confident that that was OK to do. But if you're just an open source developer and you're interested in getting involved in spec work, or you're interested in getting involved in browser work in particular, writing tests is a really great way to learn about web specs and how they work. And it's a really great way of getting involved in browser development without necessarily diving straight into C++ code or something. OK, that's all I have to say. So if anybody has any questions, now would be a great time. And please use the microphone when you ask questions so that it appears on the recording.
Hi. To what extent is this testing framework geared exclusively around rendering and browsing display side of things? And to what extent will it also cover things like network connection handling, say FTP over HTTP, think protocol differences like expect and continue, newer stuff like speedy and all that kind of stuff?
Okay, so basically the idea is that with the exception of the two examples that I had earlier, we're prepared to accept, I think, any test that you can write that is done in a way that is completely exposed to standard like web APIs. So if you can test it in a way that's browser independent and doesn't rely on specific features of each browser to get low-level information out or something, then that's absolutely fine to put in this test suite as far as I'm concerned. So, I mean, I would certainly be happy to accept like speedy tests or something. I mean, I don't know how the working group for that feel about it, but certainly I think the best thing to do would be to put it in this test suite. Yeah.
Does that include performance tests as well as just functional tests?
So far, we have exclusively done functional tests, so things that we can give a pass or fail to. I think performance testing is difficult. So I believe in performance testing. I'm not sure that it would necessarily fit well into this, but it's definitely something that I think a lot of us would like to have a more, have a centralized place to put that sort of thing.
So I'm sorry, it's going to be the only question because we are a little bit late, and there are a lot of people who want to come as well for the next talk. So what I propose you, because I understand you have a lot of questions, James, I'm sure, will be ready to answer to your questions outside of the room. Thank you, James. Thanks a lot.
Thank you.